Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P16F5 indicates a high voltage condition in the starter cut relay 1 control circuit of the Honda HR-V model years 2016 to 2022. This specific DTC triggers when the voltage level in the circuit exceeds acceptable limits, which can prevent the starter system from functioning correctly. The starter cut relay is a critical component in the vehicle's starting system, as it controls the power supply to the starter motor. If this relay fails, or there's a fault in the electrical circuit connected to it, the engine may not start. The relay is typically located in the underhood fuse and relay box, an area easily accessible for troubleshooting. Proper diagnosis is essential to determine the root cause of the high voltage reading and ensure continued reliability of the starting system. The error the DTC P16F5 represents is a high voltage condition detected in the starter cut relay 1 control circuit. The starter cut relay serves a vital function by enabling or disabling the circuit that provides power to the starter motor, directly affecting the engine's ability to start. Generally, the starter cut relay is situated in the underhood fuse and relay box, an area designed for easy access during maintenance and troubleshooting activities. High voltage may be interpreted as a sign of a short circuit or other electrical fault affecting the relay's operation. Components such as the powertrain control module, PCM, relay wiring, and connectors all interact with this relay, and flaws in any of these elements can contribute to the high voltage reading. Thus, understanding the relation and interaction of these components is necessary for effective repair. Several possible causes could lead to DTC P16F5 being stored in the vehicle's computer system. First, a faulty starter cut relay could cause high voltage readings, preventing normal operation of the starter. Second, there might be issues in the wiring that connects the starter cut relay to the PCM, such as damaged or shorted wires. High voltage in the circuit could also result from improper installation of the components, leading to unintended connections. Poor connections or loose terminals at either the starter cut relay or the PCM can create resistance and result in inaccurate voltage readings. If the vehicle has experienced intermittent starting issues or a failure to start, it is crucial to check these potential causes before proceeding to more complex repairs. The symptoms associated with DTC P16F5 typically revolve around the starting system of the Honda HR-V. A primary symptom is that the engine fails to start when the ignition is turned on. This can often be accompanied by a clicking noise from the starter relay, indicating that the relay is attempting to engage but is unable to provide adequate power. Drivers may also notice that the vehicle's dashboard indicator lights are functioning irregularly or may even flicker if there's electrical interference in the system. When using the Honda Diagnostic System, HDS, verification of the presence of DTC P16F5 confirms that there is an underlying issue affecting the starter cut relay circuit. Observing these symptoms closely can provide guidance in identifying the problem area. The first step in troubleshooting DTC P16F5 begins with verifying the problem. This involves turning the vehicle ignition to the on position, which powers up the electrical systems without starting the engine. Next, it is essential to clear the DTC using the Honda Diagnostic System, HDS. Clearing the DTC helps to reset the system and allows for fresh data to be collected during the subsequent attempts to start the engine. Following this, attempt to start the engine again to see if the DTC reappears, indicating a confirmed issue within the starter cut relay circuit. The verification process is crucial as it ascertains whether the issue is persistent or potentially intermittent, ultimately guiding further troubleshooting actions based on the results. The second step in the troubleshooting process is to check the starter cut relay itself. First, the vehicle must be turned off, ensuring safety and preventing any electrical shorts. The next action is to locate and remove starter cut relay 1 from the underhood fuse and relay box, as this is the relay being assessed. After removal, it is necessary to perform a test on the starter cut relay to determine if it is functioning correctly. A relay that tests OK indicates that it is not responsible for the high voltage condition, allowing for further investigation. If the relay does show faults during testing, it should be replaced with a new one to restore proper functionality in the circuit. In the third troubleshooting step, the next phase is to check for a shorted wire condition in the starter cut relay circuit. Begin by jumping the SCS line using the HDS. The SCS, System Connector Short technique, helps isolate issues in the wiring system. After this, the PCM connector A, 51P, needs to be disconnected to avoid interference while measuring voltage levels. Once disconnected, turn the vehicle ignition to the on mode again and measure the voltage at 2 specific test points. Test point 1 is located at PCM connector A, number 51, and test point 2 is the vehicle's body ground. An acceptable reading should be 0.1 volts or less, indicating that the ST cut REL1 Class CL wire is functioning correctly. If the reading exceeds this threshold, it signifies a wiring issue that needs to be addressed. After completing the necessary repairs, the final repair verification is critical to ensure that the issue relating to DTC P16F5 has been resolved. If the voltage checks were normal, but the DTC persists, it is recommended to update the PCM software if it is outdated. This process ensures that the vehicle's computer has the latest programming to manage the starting circuit properly. If updating does not resolve the issue, substituting a known good PCM can help confirm whether the original PCM was defective. Once these steps are concluded, it is important to recheck that the DTC has cleared from the system and subsequently test the engine to ensure it starts without any issues. Proper verification confirms that all repairs have successfully restored functionality. Implementing preventive maintenance is essential to avoid future occurrences of DTC P16F5 and to maintain the overall health of the vehicle's starting system. Regular inspection of the starter cut relay and related components can help catch any signs of wear or malfunction before they escalate into larger problems. Additionally, checking the integrity of the wiring associated with the starter circuit fosters early identification of potential faults, like fraying or exposure to moisture, which can lead to shorts. Ensuring that all electrical connections remain tight and free from corrosion can also mitigate the risk of intermittent electrical faults. By performing these maintenance tasks routinely, vehicle owners can prolong the life of the starting system and enhance reliability while reducing the chance of unexpected breakdowns. In conclusion, DTC P16F5 signifies a high-voltage condition in the starter cut relay circuit of the Honda HR-V from 2016 to 2022. Proper diagnosis starts with confirming the issue and can lead through various troubleshooting steps, including relay and wiring checks. Testing components systematically ensures that any faulty parts are identified and replaced, ensuring the starting system works effectively. Moreover, carrying out preventive maintenance habits plays a significant role in minimizing the risk of encountering similar issues in the future. By following these guidelines, Honda HR-V owners and technicians can maintain an efficient starting system, ensuring their vehicle operates reliably and efficiently for years to come. Please like and subscribe to the channel. See you next time.